students. Welcome back to the discussion on postulates of Boolean algebra. In the previous class, we have understood the four basic laws of Boolean algebra, which is law of intersection, law of identity, law of idempotency, and law of complements. Now, in this class, we will see some more basic laws because uh, it is better to get familiarized with all these basic laws if you want to get complete understanding on Boolean algebra. So let me go to the next slide. For fifth law, let me write the fifth law here. Fifth law, which is law of commutative. So the name of this law is commutative law. I think we are familiar with all these laws in our earlier classes. So there is no much difficulty in understanding this. Now, under this, I have first postulate as A plus B, which is A or B, is same as B or A. When you do logical AND between A and B, by interchanging A and B, then you will get the same result. That is the meaning of this law of commutative. In order to understand this, let me draw the tabular column again. Now, here I have two variables. That's why there are four possibilities for A and B. First, I need to know what is A or B, which is A plus B. Then I need to know what is B or A, which is B plus A. If these two are same, then I can say that law of commutative is satisfied in logical OR operation. Now, with the two variables, how many possible combinations are there? Four possible combinations: 0, 0, 0, 1, 1, 0, and 1, 1. These are the four possible combinations. Now, let me give you logical OR operation. If any one input is a high, automatically the logical OR operation gives you high output. 0 plus 0, which is 0, 0 plus 1, or 0 or 1, which is 1, and 1 or 0, which is 1 again, 1 or 1, which is 1 again. Similarly, here I need to go in reverse way. So 0 or 0 is 0. Next, 1 or 0 is 1 again. 0 or 1 is 1 again. 1 or 1 is 1 again. Now, by seeing these two entries of the third column and fourth column, you can say that A plus B is same as B plus C. This is one law which is taken from the logical OR operation. Similarly, you can go for logical AND operation. So A and B is equal to B and A, right? So here I'm giving this as a task for you. What you need to do is you need to draw the tabular column like this. Consider the two variables A and B. In third column, you need to find A and B, and in fourth column, you need to find B and A. And you need to check whether the entries in the third column as well as fourth column are same or not. When both entries are same, then we can say A and B is equal to B and A. So the commutative law is satisfied for logical AND operation. Okay. So take this as your task for today's class. Next, let me give you sixth law, which is called as law of associative. Associative law. Okay. So associative law with logical AND operation can be written like this, which is A B plus C. A or B or C is equal to A or B or C. Similarly, I can have the same type of associative property in with logical AND operation. The second thing is A and B and C is equal to A and B and C. Okay. Now here in this class I will explain this one. You need to do it on your own. This is the task which I am giving for you, and this I will do. This I will do here. Based upon this analysis, you can do it later. Okay. So let me prove the law of associative with AND operation. In order to prove this, I need three variables. Is it right or not? one for A, one for B, and another one for C. I need three variables. And first I need to know the AND means AND operation between B and C. Then I can find A and B and C. This is first thing. And here in the RHS side, I have A and B, right? So that's why I need to consider A and B. First of all, first I need to find A and B. Here I need to find B and C. And the last entry is A and B and C and C. So with the three variables, how many possible combinations are there? Eight possible combinations. What are those eight? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the possible eight combinations with these three variables A, B, and C. Now, what I need to do is I need to perform AND operation between B and C. Between these two, I need to perform AND operation. What you can understand from logical AND operation is if any one of the input is logic low, automatically the output is logic low. So for these two entries, B is logic low. That's why you will get 0. Next, for this entry, C is logic low. So output is 0. And for the fourth entry, both are high. That's why I can keep high. And for the next two entries, B is low. That's why B and C is also low. Next, for this entry, C is low. That's why B and C is low. When both are high, then only you will get one output. Now, what I need to do is I need to perform logical AND operation between A and B and C. A and B and C. Okay. So this is A and this is B, right? Sorry, this is A and this is B and C. So I need to perform AND operation between these two. Now, how can you do it? Let me show you A and B and C. So I need to concentrate on these two. Now, for the first four entries, if you observe, the input is logic low. So in AND operation, if any one of the input is logic low, automatically the output is logic low. That's why without seeing all the values for B and C, we can directly write its value as four zeros for the first four entries. Next, for the remaining four entries, A is logic high, and you need to check for B and C inputs. So in B and C values, first three are zero. That's why the output is again zero. And for the last one, here A is 1 and B and C is also 1. That's why you will get logic high output. In this way, you can obtain A and B and C values easily by knowing the property of logic and operation. By knowing the property of logic and operation. Now, let me find A and B. So A and B also. Here I need to perform A and B. For the first four entries, A is logic low. That's why A and B is also logic low. Next, for the remaining four entries, A is 1. So I need to check for B values. So for first two entries, B is 0. That's why you will get 0 again. For the remaining two entries, A is 1, B is 1, A is 1, B is 1. That's why you will get 1 as the output. In this way, you can easily fill A and B values. Then I need to make the AND operation with these two. What are the two things that I need to consider here between C and A and B? Okay. So according to law of commutative, you can perform AND operation by interchanging the terms because means A and B is same as B and A. That's why A and B and C is same as C and A and B. So I need to perform the AND between these two. But if you observe the first six entries. One, two, three, four, five, six. First six entries have the inputs as zero. When the input is zero, when any one of the input is zero, the output is zero. That's why you will get all the outputs as zero for the first six things. Next, here for the seventh value, C is zero and A and B is one. So it also has zero. And for the last one, you have C as one, A and B also as one. So you will get one. Now, let me write this with a separate color so that I can compare them easily. Now check some of the columns so that you can verify whether it is correct or not. Let me show you how to check it. Now, how can you prove this? Check this 1, 2, 3, 4, 5. This is the fifth column. Check this fifth column and check the seventh column. The entries in the fifth column and the seventh column are same. If you observe clearly, the entries in the fifth column and seventh column are same. Hence, I can say that A and B and C is same as A and B and C. This is called as law of associative with AND operation. And your task is to draw the tabular column which which says that law of associative is satisfied with the logic or operation. Okay. So I want to stop here. We will see the remaining postulates in our next class. Thank you very much for your patience.